Okay, so today I'm going to attempt to do my best to explain some of the stuff I did in episode 14 and 15 of this game. It's getting into some pretty deep stuff in computer programming, and I highly doubt that you did any of this in your 7th grade coding class if you took that. It's mainly a way to structure or organize your code so it's a little bit more efficient. It doesn't take up as much space. It's easier to use, to change. It is one of the kind of higher level concepts within computer programming. So I'm going to do my best here to show you a little bit of what inheritance and polymorphism is, which is really what the focus was on these episodes. But this is game day 12 and 13. If I go and look at day 14 and 15, not much has changed other than the enemies now shoot bullets. And by the end of this episode, we actually took out the part of the code that tested whether a bullet impacted or collided with something. So you'll notice if I hit an enemy's bullet, it doesn't do anything to my HP. I can hit all these bullets. I need to hit a bullet without an enemy. So let's, I guess, okay, so I'm hitting all these bullets. Nothing's happening to my HP. It's not testing whether I collide or not. Or if one of these enemies hits my bullets, clearly it does nothing too. So that part has been taken out so far just because it's a little bit more than what we had written in code already, and we hadn't fixed it yet. So if we take a look at some of the code itself, so the game functions the same except for the bullets being a little weird in terms of enemies are shooting them now, and bullets actually never hit anything. So actually, let's look at this. I made this here a little bit. What we are mainly doing in these 2 days with the episodes is making some of the changes that are on the screen right now. So we're grouping similar objects. That's the computer science term for a thing that we create. It kind of like the player is an object. There's all those variables like where its X and Y position is, what its HP is. All of those variables, those values are stored in the player object. So there's like this chunk in the computer memory that when you create the player, it gives you this chunk of memory. And what's in that memory is all the variables. All of what I'm going to show you today are some of these methods, these functions, can be stored with that player. So when you call player.x, it will pull up the player's x position. If you call player.update, it's going to update the player. So we've kind of started to group these into similar things. So all of the things that we're creating on this game that we can interact with, that we can see, are similar to each other. So we called them, or starting to call them entities. They're just things in the game that share some properties. Some of those properties are everything on this game has an X and a Y position. So why create it 4 different times? Why have a way to make a player X and an enemy X and an upgrade X and a bullet X when you can do it with this one kind of super object or super class? It's the bigger group that contains a bunch of smaller things. So we're going to kind of implement that, make that happen where we can create objects, all 4 of these things, the player, the enemy, the upgrade, and the bullets, using the code that's in the entity function. Okay. So some of the things that all entities do is they all have to be able to draw themselves. They all have to be able to update their position every frame that goes by. Every 40 milliseconds, I think, is what we had. They all have to be able to test whether they collide with an object, and they all have to be able to update themselves, which really means this update function calls these two others. It will update their position, and then it will redraw it. So that's what the update does. And that's what all of these different objects, these different entities in the game do. They all have to do those four things. So it makes no sense to have four different functions written four different places for all four different types of objects. So if you make a change, if you screw up on the update position function in the upgrade, and you notice it when you're working on the upgrades, if you have four different versions written in each one of these different objects, you have to change it in four different places. Where if you put it in the entity, then one change will affect all four. Okay. The other thing, we have kind of a subcategory here. Each one of these are kind of called the children of this entity function here. So we have another child that's actually the parent of two others. So we have actors. These are the players in the game, and I couldn't really think of a better term for a player. It's the, like, enemies aren't really players. They're controlled by the computer, or at least our code. So, but they still can interact with the player. So they can shoot bullets, they can have an HP, they can do the same things that a player can do, in theory at least. So they are considered an actor. So we're going to have some functions that players and enemies both can do. If we take a look at our game, both players and enemies can shoot bullets. So an upgrade has no reason to shoot a bullet. That little yellow guy there. A bullet has no reason to shoot another bullet. So players and enemies share some traits that are similar with each other, so we can group them together. We don't have to duplicate code. Okay, so let's take a look at some of this actual code. Really, what I wanted you to get from this is just to see the groupings and how there's some similarities between all these different objects. Okay, now if we kind of take a look, I don't know if I'm going to go through all of them, but let's just kind of follow along here. If we look at the player. Okay, so when I create a player, where do I actually create my player? I think in the new game. Nope, it's in right there. Okay, so way at the end of my code, I create a player and I store all these values in the player variable, which is going to be my object. Okay, so what it calls is it calls player. So if I go way up to the top, it's going to search for the player function, and this is what it calls. So it finds player, and the first thing that happens is we call actor. Okay, so that's what it's going to do is it's going to look for the actor function, which is right down below here. So instead of doing all this code first, since I called my function, I said actor, and I passed it a bunch of parameters. So my ID is going to be player. I'm going to call my type is player. My ID is my ID. It doesn't really matter with the player since there's only one of them. And then I give it some numbers like 50 and 30 for the X and the Y, speeds of things. And how you know what you're passing here is the actor function. You spell out what you're passing. So my HP is my second to last. I start out with 10 hit points, and I have an attack speed of 1. And I'm going to be a green color, and I'm just passing all those things to this. So when I get to actor then, what we notice is the actor actually calls that other, the super class, the entity, the one that contains the actor and this thing here. So I called player first. That said, hey, you should go to the actor one and do all the stuff in there. And then in the actor one, it actually called the entity first. It says, before you do the stuff in the actor, do all the stuff in the entity, and then we'll finish the actor stuff, and then we'll do a few things that are only for players. So it's a way of organizing this. And if we take a look in a little more detail here, if we go to entity, this entity, remember, is things that all of our stuff use in the game. So whether you're an upgrade, a player, or anything like that, you're going to use the stuff that's in the entity. So what we do in the entity is we pass some of those things, the type, meaning like, are you a player, are you an enemy? We pass an ID, an X, a speed for X. All these things get passed and we set them equal to that. So we create a type variable. Now you might notice that we use a lot of selfs here. So really it doesn't need to be called self. I could have called this A. I could have called it supercalifragilisticexpialidocious. It doesn't matter what I call it, but it's just kind of a convention. Something that a lot of computer scientists do is when you are in these kind of superclasses, these big categories that apply to a lot of different things, you call them self. So whenever you refer to the object that you're dealing with right now, you usually call it self, and you can refer to it as self throughout this whole thing. So you see all my highlighted stuff. Instead of saying player, I just say self, meaning the object that I am creating right now, or I'm looking at right now, or I'm using right now. Okay. So what I did is I created all these variables, which every object, whether it's an upgrade, an enemy, a player, has. And then I created functions for it. So when I later on want to update my player, all I have to do is say, like, this isn't where I would put it, but just so you can see it, I would do player.update. And since there's no parameters here, it's just empty brackets. So that's what I do to do the update function now. Instead of what I would have done before is I would have said update, oops, and then I would have passed the player object to it. So I would have called my update function and I would have said, who am I updating? I'm updating the player. Seems a little bit kind of pointless at this stage, but it does give you a lot more flexibility because you don't, whatever object you're dealing with, you can just call its own personalized, customized, slightly different function than maybe another enemy, another player. So you can create a little bit more functionality or can customize things more. Okay. So then I draw things. None of this code in here has changed from the last episode. I've just, instead of having a update function somewhere else where I go update equals function, and I do it that way. Now I'm creating a function that's stored in that variable, in that chunk of space in computer memory. Okay, so I called the draw, I called the update position. I have get distance in between, which I actually don't think is used anymore because we have all rectangles. And then I have my test collision here. So I create all of those functions for my player object, and then I return self. So functions, a true function has to return something, like it has to give a result. So what I'm doing at the end here of my entity function is I'm returning my variable self. So self has this method here, test collision. It has get distance, it has update position, has draw, has update, and it has these, 8, 9 variables. So that's what I'm returning to my player. And I created another variable in the player called self. And what got returned here was self, but it's not the same self here because it's in a different function. So I returned all these things up here that I just talked about, my variables and my functions. Okay, now what I notice here right away is I have an update position here, self.update position. Pretty sure I had one of those up here too. Yes, I did. But they're different. Okay. Because what this is doing here is it's taking your self.x, so your x position, and it's adding your speed x, or your y, and it's adding your speed y. That's what the enemies do in the bullets, because they move around on their own. They already have their own determined speeds and paths, pretty much. But the player has to be moved with the keys. So the keys are how we do it here. So what I'm doing is, even though I already created an update position in the entity, this isn't the right update position for a player. This works perfect for your enemies and your bullets. It technically would work for your upgrades. They just don't move, so your speed X is always 0. It does not work for your player that has to be moved with the keys. So now I've kind of erased or overridden, I've saved over the original update position, which doesn't work for players, and I've created a customized one for a player. Okay, so I've created it. It works for a player, but it wouldn't work for an enemy. So this is where I do it. I do it in my player function. I wouldn't want to do this code in the entity because there's 3 things that use the update position code that works for 3 things. I wouldn't want to change it in the actors because the enemy updates its position or moves differently than the player. I'm going to change it in the player code here. Okay. So that's what this does. It's the same code I had before. I just put it in a slightly different place. I haven't changed anything. I'm just reorganizing. But the reason why I do it in the player is because the player doesn't move like the other entities. It moves with the keys being pressed, whether it's A, S, D, or W. Okay. And then here's a couple variables that only a player use. So if you press down, you press up, you press left, you press right, that only affects the player. So you only need to have those variables for the player. And I kind of jumped ahead of myself a little bit here. After the entity, we actually go to the actor before the player. So we called the entity, and once I'm done with entity, I do this stuff here. So there's a couple functions that are shared by enemies and players. So the update function, okay, what this super update thing is here, this is something that we haven't seen yet. So I know I've mentioned in the video before, but when you have an object, the parent or the object it kind of belongs to above it, where is it? Here it is called its superclass or super object, those kinds of things. Sometimes it's called parent as well. So the player, if I have a function in the actor that I want to use, I can call it super, just to keep track of that it's not the player's function, it's the parent's function, the one above it. Okay, so what this really is doing here is I created a variable, I called it super update. I could have called it anything, but calling it super means it's the update function in the level above. So it's the update function in entity then. Since this is actor, the one above actor is entity. So if I go look at that, okay, update. Where's it? There it is. Okay. So all I'm doing here is I'm saving this function here. I'm saying super update equals entity.update, or however I worded it down here. Where is it? Okay. Equals self.update. Okay. So I'm saving the original update code, which had 2 lines in it. It called update position and draw the character, the actor. So why I am doing that is because I'm using this variable. I had to store it before I change it. So right here, I'm overriding my original update function. So the moment I write this in code, it makes that update function blank. There's nothing there. So I need to save it to store it before I update it here. And then the first thing I did is I called that variable that I just stored it in. So I want to do those two things in my update function. I want to draw the new position and I want to update the position before I draw it. I need to do those two things, but there's one other thing I need to do with an actor is I need to also increment or add my attack speed to my attack counter, which if you remember correctly, I think we had to have an attack counter of 25 to shoot one bullet. So that's how we figure out if we can shoot a bullet or not, is we have to add to our attack counter by our attack speed. So a upgrade doesn't need to do this. A bullet doesn't need to do this. Just the two things that shoot bullets need to do it. And those are both in the actor category. So they're enemies and they are players. So that's one way to kind of make a more customized function. I can save the original one, call it or write it in and use it, and then do whatever else I need to do that's customized, right? And then the other stuff that hasn't changed, I just put it in the actor category here. The actor class is self.perform attack and perform special attack. So only enemies and players need to attack at all. So that's where they get put, is in the actor, since that's the superclass, the group for both actors, for both enemies and players. Right? But it's the same code that it was before. And then some variables at the end here that only actors have. They have HP, they have an attack speed, they have an attack counter, and they have an aim angle, since they can shoot bullets. Okay. So you'll notice that this aim angle right now is 0. It defaulted to 0, and that's why the enemies are always shooting to the right now. Wherever they shoot a bullet, they're always going to the right before they bounce. So there's no function in here right now to kind of make the enemy shoot in all sorts of directions or towards the player or anything like that. It's just all 0. Okay. And then I return self again. So all these things I just created in this actor class, this actor constructor, I think they're sometimes called. All of this stuff gets returned to the original place where it was called, which is the player. And then I overridden my update position. I create a few things for the player that only the player needs, because only the player can be moved by key presses. And then I return self again. So everything that has been done at this point in this self variable here is not just the player stuff. It is everything that the player function called. So it went into actor, it did everything in the actor, and that's in this self variable in the player. It also called entity. So it went through and it did everything in the entity and returned it. So this self right here, what I am returning in the player function, is actually got stuff in it from all 3 levels of structure here. So I've got stuff from entities, I've got stuff from actors, and I've got a few things that are only applicable to players, meaning the button press stuff. Right. Now, this whole concept here, and I'm only going to walk us through the player, I think. I did similar things for the enemy and the upgrades and the bullets, just reorganized things. But it would be way too long of a video to go into all that stuff in great detail. But there's 2 terms in computer science. We've got inheritance that we just went over, and we have polymorphism. Right? Inheritance pretty much means that This actor group here, this actor category, inherits all the stuff from entities. And how we can show you that inheritance is every time I call the actor function, it calls the entity. So it's going to inherit or have all the stuff that the entity function did because it calls it. So since I call entity, it does all this stuff, and every actor has all the features, all the variables, all the functions of the entity. That's what inheritance is. And that's kind of why I've been calling these things like parents, and the things under the parent are called children. So you inherit things from your parent, you don't inherit things from your children. So that's inheritance. It's just getting things from a parent class or a superclass, that category one level above you. And then polymorphism. We actually had some good examples of polymorphism in the player here. Poly, like polygon, means many. Morphism is like versions or forms, morphs. So many forms, many versions of a similar thing. So one way to do that is have the same function names. So like player.selfUpdate here. There's another one, like I mentioned, up in the entity. There's an update position, but it's got different code in it. Same name, different function, different code. So that's what polymorphism really is the ability of a computer language, of a variable, of your code to have the same name for a function, but it's stored different code. So it's got different stuff in it. It does different things. It has a different function. So it's a polymorph. It's a different version of the same thing. And that's what polymorphism is. That's what a lot of the stuff that was done in this video, these two videos, attempted to do. So just before we go on, really you see that enemy calls everything an actor, actor is going to call everything an entity, but unlike player, there's really nothing that needs to get overridden. So it really just does the stuff in actor, does the stuff in entity, and doesn't have any special things for the enemy at this point. All it does is it says whatever in my enemy list, I'm going to use my ID, which I gave to it, and that equals myself, which is the stuff that's in the actor and the entity category. Okay. And the only other thing that might be worth putting in or mentioning here is where is my update? Okay, this is the one line of code that's probably different from the last version, not in terms of where it is in the code, because I changed a lot of that stuff in this video, but in terms of the actual functioning code. This is the only different line from episode day 12 and 13 to day 14 and 15, because before we did not have enemies that shot bullets, but now we do. So every time I call the update function, which is kind of the main working function of this game, and it's called by this function at the very last part here, and it's called every 40 milliseconds. So every 40 milliseconds that go by, it's going to go through every enemy in this list, and it's going to perform attack. So if that enemy can shoot a bullet, it's going to. So that's really the only difference in the code in terms of actual functioning code, as opposed to reorganizing it to be polymorphic and have some good inheritance. Okay. I know the next couple videos are starting to get into some visual effects. So like instead of having boxes or rectangles that go around the screen, we're going to have like images floating around. Make the game look prettier, I guess. So with that, I will see you next time.